about like the curves and stuff, it's like
Okay,
crazy.
I call it integrals and volumes. Okay,
Yeah. Okay.
three-dimensional. Is
Yeah.
that what it is?
Yeah.
Probably. All right. Do we have a Jamboard yet made up?
Yeah. Yeah. It should be shared with you. I think it's called Unit 7 or something. Oh, AP Calculus AV
Oh, I see
Unit
it. You
7.
shared it a while ago. Okay. All right. So tell me what you know how to do with these things. Like, tell me where you would start with this.
To be honest, the X value kind of throws me off. That's where it makes it hard for me to start off somewhere. Like the L and X value and the E of T throws me off a lot.
Okay. So
I've been kind of confused this whole unit.
all right. I might need your help with some of your notes and things like that.
Okay, we do have answers.
Okay. Well, all right. Well, we can just try it that way. There's a few things that it takes me a while to kind of, because I don't do this very much. But I feel like it usually, don't you want the variable on the top? Usually
For a U sub?
when you're doing any of this stuff, don't you usually want this variable to be on the top, or does it not matter?
Let me check. I'm gonna go to my stuff. Wait up. Let me see. No.
Actually, I think I'm thinking of the fundamental theorem of calculus, maybe. So I don't know that I need it up there for right now. Well, let's just talk about how you would do this problem, okay? And if I get it wrong, you can check your answers. So the first thing is to recognize that you can take the integral of each one separately, right?
Yeah.
Okay, so what's the rule for the integral of t? Remember do you have the notes for the, I'm sorry, e to the t? What's the integral of e to the u du equal to?
E to the U du.
Do you have your cheat sheet of your integral shortcuts?
So here I have like two separate parts. It's like e squared plus 2 times 0, and then e ln x plus ln x over 1 over x, and then x over 1 over x plus 1 over x ln over x, and then you get 1 minus ln x over x. That's
okay. Do you have like a formula sheet or something that you're using?
For E, I think we do, but it's somewhere way back in my notes. Let me check. I've taken so many notes in this class and other classes. That's with volume.
Well, I'm just looking one up. I'm looking one up. It's just one. It is e to the u du is just e to the u. The integral of e to the u is itself.
Okay.
And so sometimes you have to convert this, but if it's sometimes if these two things aren't the same, you have to do a little bit of fancy footwork to get this to work. But when they are the same, you don't have to do any fancy footwork. So this is just going to equal e to the t, and it's going from ln of x to 2. So we'll plug those in a second. And then what's the integral of t?
1.
It's, remember how you do the opposite of what you would do with derivatives. With derivatives, you would have.
Oh yeah. It's half. It's like you do a inverse or a reciprocal of the power. So it's like
you add 1 is what you do. So the power is 1. You're going to make it 2, but then you divide by that.
It's half t squared. Yeah, you're right.
That's right. So it's t squared divided by 2.
Yeah.
And then that's again from ln of x to 2. So now we plug those in. So this is e to the 2 minus e to the ln of x, which is going to simplify. We'll do that in a second. Plus 2 squared over 2, which is 2, minus 1/2 ln of x squared, which we can simplify that as well, right?
Yeah.
So this just simplifies to x. So it's e squared minus x plus 2. And then remember with logs, let's see, we're not squaring. What are we squaring here?
ln of x.
ln of x times ln of x, which isn't the same thing as ln of x squared. So I can't take that 2 down to the front. So I think we just leave it like this. 1/2 of ln of x squared.
See. I can always check the answer key.
Yeah, let's see how we did on that first one.
Okay, let me go pull up it first. Sorry, I didn't have everything. I just got it.
That's all good. I'm going to peek ahead at your next one while you look at that. Just check.
Okay. Hold on, I clicked on unit 6 like a dummy. Wait up. Okay, now I'm opening unit 7. You know what the good thing is? My teacher's giving me like unlimited time to retake it. So I have as much time to study before I even take this test.
Oh, that's good.
I'm just on the AP exam, like studying part. I'm gonna just do this and study for everything else at the same time. I'm trying to up. There you go. Now it's loading the document. Wi-Fi being a little slow right now. Come on. I mean, me and you used to cut out a lot, actually. I think on my PC. So.
Right.
Oh, why is it doing this? All right, let me just download the document. It's being a little annoying. Why is my computer being so slow?
That's okay. I'm spending some time reviewing.
Oh, wait, now it's loading, I think. There we go. Okay, it's loaded. All right, well, the answer for this, it says it's -1 minus ln x over x.
Oh, -1 minus ln x all over x.
Yeah, that's what they got.
You sure that's number 6?
Yeah, I'm very, very sure. Number 6, 2, the integral of 2 to ln x et plus t dt. I think they found a way to cancel out the t's, I'm pretty sure, or eliminate all the t's.
Okay, so
Yeah, e of ln equals 1, right?
so does that mean that we weren't allowed to split it up like this?
I don't know about that, because another person's work shows that you are allowed to split it up like that, but I think they like factor out an x out of everything or something. It seems.
Okay, so could be a formula that you could have memorized, but I don't know why that wouldn't have worked.
Problems. It's okay. We can go back to it later. It's fine. It's fine. Don't worry. Don't worry.
Yeah, yeah. Let's come back to this one because because this isn't a product, so we're not going to use integration by parts.
Yeah.
I don't know why we can't just do that, but I'm sure what I did was wrong. I guess what it was, but it felt like what I was doing was right. But like I said, I haven't done this, especially with COVID. I haven't done this in quite a few years. That didn't look like a very difficult one to me. So I'm surprised that I didn't get it right. I'm wondering if I could have simplified it any differently? No. Okay, well, let's come back to that one. I'm not sure what to tell you about that. So for
we don't
these
have to do all
problems,
of these. We don't have to do all these.
yeah, for these problems, it says this is the graph of f of t, and picture to the right is graph of f of t. Okay, so this is f of t right here.
Mhm.
This graph is the graph of f of t. And what they're saying is that f of x is the integral from -6, which is right here, to 2x, to double x of this function right here, of this graph. And remember, what the integral means is the area under the curve, or the area between the curve and the x-axis.
Yeah.
So you can see right here
that right there is pi. That's 2 pi, right? No, is it pi or 2 pi? I forgot.
It would be whatever half of this circle is.
Okay,
So
I think that's pi then. I think that's just
it's pi r squared, but then it would be half of that. So 4 pi. So yeah, this would be 2 pi right here. So we can write that in here. 2 pi. The area from here to here, or we can go all the way up to here, I guess.
Yeah.
Is half of this triangle right here. Right? So it's 3.
That's a 3 by 3.
Times
which is
3, that's 9 divided by 2.
Which is 4.5.
So 9 halves. So this area is 9 halves right here. I'm sorry, this is a negative pi over 2 pi, not 2, right? Because it's below the x-axis.
Yeah, I think so. Or it depends if you're going backwards, I guess, with the derivative. Yeah.
This right here is going to be 2 full units plus a half. So this is 2.1 or 2.5.
Yeah.
Is that how I got that?
One.
And this last one is 6. That's right. So those are the different areas broken up.
Yeah.
Negative is below the x-axis, positive is above the x-axis, and you can see that. So now let's figure out what this 2x means up here.
Yeah. This 0. So I'm gonna go on the Jamboard so I can see the problems better going on it right now.
Oh, okay. Are you not able to see it as good on Zoom?
No, because my thing's not full screen. I'm kind of like switching off between screens.
Oh, okay. Yeah, that's a good idea. So this up here, the fact that there's a 2x up there, that kind of worries me a little bit. What does that mean as opposed to if it was just an x?
Well, I mean, that's just multiple. Is it something complicated?
I don't know.
I mean,
that's what I'm trying to figure.
0, it's with 0, it's just it's 0. So like for number 7, it's not going to change anything else up there.
Right. That's true. That's true. Yeah. So you're right. No, you're absolutely right. What we have to do is plug in the value up into here and then calculate based upon that.
Yeah.
So find the value of f of 0. Well, we would plug 0 in for x. So it's from -6 to 0. So it would be, what is this? That's 1. No, that's 2. This is 2 right here. And this is -2. So this would be 2 minus 2 pi.
Yeah.
Right?
Yeah, that's exactly what it is.
Okay. And then for number 8, it says find the value of f of -1/2. So I'm going to plug -1/2 up here.
-1. Right.
That's -1, which is to right here, which is
half
positive 1/2, right? It's 1/2 minus 2 pi.
Yeah.
Got it?
Yep.
All right. Now here's where it gets to the fundamental theorem of calculus.
Yeah.
You see how they wanted the derivative? What's the derivative? So the derivative of this is going to be it's going to be where that's where the 2x comes into play, because you have to multiply it by 2. So basically what it is 2 times whatever you get when you plug in -2 into the actual function.
Yeah.
Right? Do you remember that? So the integral and the derivative kind of cancel each other out,
Okay.
except for the fact that this is a 2. You're going to have to double your answer.
Okay. So this is 0?
So normally it would just be f of -2, and
Okay.
f of -2 is 0, right?
Yeah.
So that's 0. So it's going to be 0 times 2, which is still 0.
Yeah.
Do you have the answers for these, by the way?
Yeah. I'm very sure that was 0.
Okay.
I'm
So
90.
this next one, it says find the value of f prime of 2.5. Well, 2.5 is going to be right here. It's going to be 2.
Oh, well, they said it was 4. -4, -4, -4 is the answer.
Right. I'm not done yet, because 2 would be your answer. But then it should be +4, shouldn't it? The derivative of 2x is 2, so it should be 2 times 2, which is 4.
Wait, can you backtrack a tiny bit? Yeah, that one's 4. Number 10 is 4. Number 9 is -4 though.
Number 9 is?
Yeah.
I thought you said number 9 was 0.
I thought it was 2 from what, and then I went and checked and it's not. It's -4.
Oh yeah, I'm an idiot. Sorry. Look at it. We forgot to plug in -2. What's -2 times 2?
-4.
It's -4, and the value here is -2.
Oh.
So it's -2 times 2, which is -4. Yep.
Okay. Okay.
Sorry, I made the mistake. All right. Find the value of f double prime of 0. Well, f double prime, well, f prime of 0, and then we just take the derivative of that. I'm guessing it's going to be 0.
I'm pretty sure it was 4.
All right, let's find out. So f prime, I think what we do first is find f prime of 0. So that's going to equal 2 times 2, which is 4. And f double prime of 0 would just be, wouldn't that just be the derivative of 4? And isn't the derivative of 4 0?
Oh, yeah, that makes sense. All I'm
you're
gonna
telling
say
me
is
what's
my
the answer?
teacher purposely put one wrong on this entire packet to like catch people if they were like just writing his answers down.
I don't know if this one is necessarily wrong, but I feel like to find a double derivative, I feel like you have to first take the derivative and then take the derivative again.
Yeah.
And if the derivative is a constant, then the double derivative is 0, because the derivative of a constant is just 0.
0. Yeah.
Right?
Yeah, I agree too.
I feel like the answer is 0, but I could be wrong. What did you say the answer key said?
4. That might be the one incorrect one.
I would say ask your teacher about that, just to make sure.
Yeah, I have time. Don't worry. I have time.
Because I might be doing something wrong with that.
Okay.
Yeah. So the next page 3, it says if g of x equals that mass, find each of the following values in question 16 and 17. Find the value of g prime of 1. So this again, if I'm taking the derivative of an integral, if there's nothing fancy about it, see how it goes from 0 to x, then it's just going to equal this with that plugged in for the variable.
Yeah. Yeah.
That's, I believe, the fundamental theorem of calculus. So this would basically be 1 cubed times e to the 1, which is just e.
Yeah. And that's, so yeah, that's just e. Yeah. Let me check.
Now find the value of the double derivative. Well, here's that same question. So I feel like how I'm talking about doing it is not the correct way to do it.
So it looks like from this thing, like it wants you to find the double derivative of
Right.
x, then input it in, kind of, I think.
So if I take the derivative of this, it would be 3t squared e to the t. That's the derivative.
Yeah. And then you input
and
one.
then do I do it?
Let me check.
If that was the case, it would be 3. I don't know if this is right, but it would be 3e.
X3. I think they did a product rule with it.
Oh yeah, duh. I'm an idiot. That's not the derivative.
I blanked
the
out on
derivative
product rule
requires
too.
if t cubed et is your function, then the derivative is 3t squared e to the t plus t cubed excuse me, e to the t. Yep. So now if you do that and you plug it in, you're going to get 3e to the t plus e to the t, or sorry, 3e plus e, 4e.
Yeah, yes, exactly.
Is that the answer?
4e is the answer. So that's,
There you go.
I think 4e is where you're getting it
So
from.
let's go back and do this one over again. That's not the way you do it. I'm an idiot. What you do is you take the derivative at that point, at the point 0.
Mhm.
You can see the function. Let's come up with the equation of that line, maybe.
Okay.
But it's still going to be linear. So I don't quite get this. So the equation of that line is the slope is 1.
That linear function, that linear positive
so it's
slope.
just x plus 2.
Yeah.
So what we do is we take
Derivative of that.
the integral. Yeah, so the derivative of that is just 1. The integral from -6 to 2x. But this doesn't make sense to me because we don't have the actual function in this. So that doesn't make sense either. What did you say the answer was for number 11?
I think it was 4. I'm very sure it was 4.
-4.
Check. It was 4, not negative. Just positive 4.
I'm trying to think logically about how you would do that. How would you find the double derivative from the picture?
Oh. Maybe we should just go back to that one as well. We got most of them.
Number page, page 2 you're talking about?
Yeah. If we don't know it, we should just skip it and save it for later, because
I don't know. I'm so sorry. I don't know how to do that one. I don't want to waste your time. Just go ask your teacher about those. This is more like my style right here.
Yeah.
So this is going to be a U-substitution problem.
Yeah, I need to work on these.
So we're going to let U equal 1 minus 2x squared. Okay, and that means that du equals.
Yeah, wait, what do they always do with du? Do they take like a derivative and put a dx behind it? I'm always so confused.
Yeah, so the derivative of u with respect to x.
Okay, yeah, that makes more sense. So they take the derivative. Okay, derivative of u. Okay.
Yeah, this is the derivative of this u with respect to x.
Yeah, okay.
is going to be, just take the derivative of this and you get negative 4x, right?
Yeah.
But now you got to figure out a way to rewrite this in terms of u.
U. So
Okay.
it's 2x root. I mean, cube
So
root.
I'll just show you the way I like to do it the best. So I'm going to rewrite this, and I'm going to rewrite it as this: the cube root of 1 minus 2x squared. And then I'm going to write the 2x here, dx. But then I like to say, well, I need negative 4x here. So I multiply this by negative 2. That gives me the negative 4x, but then I have to balance that out on the outside by multiplying it by the reciprocal of it.
Okay.
So do you see how in blue I added basically nothing to this problem?
Yeah. Yeah.
That's how I like to do it.
Okay.
So now you can see that this right here is u, and this is du. You see that?
Yep.
So it's negative 1/2 integral of the cube root of u du. And let's even write the cube root as 1/3 power, right?
1/3 power. Exactly, yeah.
And now to find the integral, that's just u to the 4/3 power. I'm adding 1 divided by 4/3.
Divided by 4/3, not multiplied by
Plus c.
3/4.
Yeah, you divide it by whatever the new exponent is.
Okay. And you
Got
just substitute u with the actual u, which is 1 minus 2x squared.
So now flip it. Yeah. Well, now I'll flip the denominator, right? Multiply by the reciprocal. So that's negative 3/8 u to the 4/3 plus c, which is negative 3/8, and your u is 1 minus 2x squared to the 4/3 plus c.
Let's see. That seemed pretty easy.
Did we get it right?
Yeah, that has to be right. I bet it's right. 21.
Oh, let's just make sure. It's been a while for me.
It's right. It's right. It's right. You just did 1 minus 2x, which I think is wrong. But no way. There's no way.
What did they say?
Yeah. No, it's just there's no 2x squared in there for some reason.
What did they have in their answer?
It's negative 3/8 parentheses 1 minus 2x.
Yeah, that's a typo, I think.
Okay, yeah.
Because it should be 2x squared.
Yeah, I agree, because that's what u is.
Yep, I'm pretty sure that's a typo.
Yeah.
All right, so now we're using U-substitution again. I don't know if
just
we need to,
do one of them.
do we really need to do U-substitution for this one?
For the first one?
I guess. So let's
think
let u equal x plus 2.
Yeah.
So du equals dx.
Dx, yeah, that's it.
So basically we have from 1 to 3 of u to the 5th. You didn't really need u substitution because there wasn't anything fancy to be done here.
Yeah.
Du.
And then you just do.
So that's u to the 6th over 6.
Yep.
From 1 to 3, which is x plus 2 to the 6th over 6 from 1 to 3, which is 3 plus 2 to the 6th over 6 minus 1 plus 2 to the 6th over 6, right?
Yep.
Which is just 5 to the 6th minus 3 to the 6th over 6.
I do not. Yeah, put that in. Por favor. Why does it say no? Oh, maybe that's what. Oh, is it just 2 to the 6th Or wait, no, that's not how power works, right?
No, that's not how power works.
Yeah. Divide that by 6.
I don't know that there's an easier way to do that.
Yeah. How do they expect us to do that without a calculator?
Yeah, that's not even a pretty number.
Let me check what the answer is.
Let's divide that by 2. So that's going to be 7.
Oh,
4,
they don't
4.
go any farther. They don't go any farther. They just go to where it's 5 to the power 6 minus 3 to the power 6 divided by 6.
Got it.
That's all they go.
Okay. Yeah, that makes sense. So for this one, we do need to use U-substitution. So U
Yeah.
equals 4x minus 1. So what's du equal?
4x minus 1. That'd just be 4, right?
4 dx, right?
4
So now
dx,
let's
yeah.
do that little trick I was talking about. We're going to call this 4x minus 1, and we want to make this 4 dx,
Yeah.
right? We want to make this 4 dx. And if I'm going to put a 4 in here, what do I have to put on the outside?
1/4.
Perfect. That's it. So now I see there's my du. There's my u. So this is 1/2 power. So that's u to the 3/2 divided by 3/2.
So you just
Plus-
multiply those fractions.
Yep, flip and multiply. So 2 is going to cancel. So you're going to get 1/6. Because 3 times 2 on the bottom, 1/6 u to the 3/2.
Wait. Dividing by 3/2 is the reciprocal of 3/2, right? Yeah. So it's 2/3, right? That
Yeah, but the 2 and the 4 cancel.
You just multiply when it comes to the thing. Do you know what I mean?
Say again.
Like when we do when we take the backwards derivative of something, like
Yeah.
we don't like divide, we just do like
Oh,
2
got
over
it.
3, the
Yeah, that's fine.
reciprocal.
That's totally fine.
So
But
1/4
essentially,
times.
really what you're doing, just so you know, what you're doing is dividing by that.
Yeah,
It's the
I
same as
see.
multiplying by the reciprocal.
So yeah. Oh yeah. So now it's 2/12, which is equals to 1/6. Yep, that makes sense. Okay.
I was just reducing it as I did
Yeah.
it. So this is 4x minus 1 to the 3/2 power plus c.
So yeah. Which you could just say 4x minus 1 divided by 6 plus c. Yep.
Yes, you could.
3/2.
Yep.
3/2 power. Okay. Yeah, that's easy. Okay.
All right, so now they want us to separate the variables.
Yeah, I didn't know how to do these ones.
Trying to remember. So I feel like I'm just going to kind of wing it here, okay? If I cross multiply, I'm going to get y cubed dy equals x squared plus 6x dx.
Yeah.
Okay. So now if I integrate both sides,
That's what you do end up doing. You do end up make sure I can
feel like now I can just, to solve this, I'm going to integrate both sides. But I'm trying to think if I have to integrate. This is separation of variables. So I think for this, all I have to do now is say that y to
exactly, yeah, that's how you exactly do it, it seems.
Y to the 4th
What
over
you put it
4
in?
equals x cubed over 3 plus 6x squared over 2.
6x squared over 2. Yeah.
Is that right?
Yeah, 3x squared, right? That's 3x squared basically, right?
Yes.
C.
Yep. Plus c.
And then you multiply by 4. I don't know where you get that from.
Yeah, the reason you multiply by 4 is because you just want to solve for y. You want to isolate. So multiplying by 4 will get y by itself.
Okay.
If I
Oh, I
multiply
see.
everything
Yeah,
by
knocks out that fraction.
yeah, so it's going to be 4 thirds x cubed plus 12 x squared plus, you could still call it c because it's still just some constant.
Yeah.
And then are we going to take the fourth root?
Is there like there's like cube root? Is there like so wait, no.
Do you know what the answer key says?
No, that's right. Whatever you're doing is right.
Fourth root now?
Yeah, it's the fourth root, and then that's the most simplified it gets. You don't have to do 38. Don't have to do 38.
I was thinking integration by parts, but no, that's not needed. This is just separation of variables.
Yeah.
So now for this one, we're going to do kind of a similar thing. We're going to multiply the dx over, and we're going to divide the y over. So I multiplied the dx over, and now I'm dividing the y, so I separate the two variables.
Wait, why do you divide the y?
Because I want the y to be over with the dy.
Okay.
You get it? See how I separated them? I moved this over here, and I moved this over here.
Oh, yeah. Okay.
Okay, and now that's just like 1 over y dy equals 4x dx. And now I can take the integral of both sides. So what's the integral of 1 over y? Isn't that ln of y?
Yeah, I'm very sure it's ln y.
I believe it is as well.
It has to be that because yeah, ln equals 1 over u. So ln of y is correct. That has to be it.
Yeah. I'm looking at my cheat sheet here to make sure, but that's what I remember too. Yeah. So this is ln of y equals 4x squared over 2, which just equals 2x squared plus c.
Yeah.
And now I'm going to try to get y by itself by.
So you can put e on both sides.
Base e of both sides. Yep.
Okay. So that's what you do when you have ln. So you can get 1 on a side.
2x squared plus c, e to the 2x squared plus c, which could also be written as which probably is written as e to the 2x squared times e to the c. Is that how they wrote it?
Yeah, I think you just do y equals e 2x squared like c. You could just put c in there because it's multiplied.
So times c,
maybe plus c. Then you just add c.
Well, this is.
I think it's the first one you had before. Yeah, that okay. One.
They're both the same thing. I just didn't know how they wrote it.
Yeah, that makes sense.
Yeah, remember how logarithms, how you undo a log, you exponentiate both sides? Yeah. So that's that. See, I can do this stuff. The first stuff you're talking about, I have to look at a book. I don't quite remember how that stuff works.
Yeah.
Solve the following initial value problem. Okay, so what we're basically going to do is that same thing we just did before, but then we're going to solve for c by using your initial value. So this helps you solve for c.
So, okay, yeah, I can see what you mean. You just equal, yeah, I know what you're doing. Yes. So we need to find
so let's separate. Let's try to
you need to solve the differentiation equation by solving like by the separation of variables, and then you input x in there. You input 1 to equal 0.25, and then you figure out from there.
Exactly. Yeah. You got it. So this is going to be y to the -1, negative y to the -1, right?
Yeah.
equals negative 2x squared all over 2. So just negative 2x squared plus c. So
Yeah.
this is negative 1 over y equals negative x squared plus c. So let's just,
Wait, why'd you get negative y over -1 and not ln y squared?
because this is y to the negative 2. And
Okay.
how do you take the integral of y to the negative 2?
Okay. Okay.
You add 1, so it's y to the negative 1, and you divide it by that negative 1.
Okay.
Got it?
Yeah.
So now I'm going to multiply both by negative 1. And now flip both sides. Can I do that?
Or you could do wait, no. Could you do ln of y?
No, you don't want to do ln. ln, you only take the natural log if a variable is in the exponent. You're thinking of the integral. We're done taking integrals. We're just trying to solve this algebraically now.
Okay.
The thing that I'm confused about is the c. So technically it's 1 over x squared plus c. Technically.
Yeah.
I think. But now, in order to solve for c, we're going to use that initial value of y equals 0.25 when x equals 1.
Yeah.
So that means c equals 3.
1 over 1 plus, wait. Sorry, yeah, let's just get that. Sorry, that algebra part just hurt my brain for a sec. Yeah.
Just tell me if that answer's right, then I'll explain it to you.
It's just this like 0.25 equals 1 over 1 squared plus c. It just looks so weird in my head.
All I'm thinking to myself is 0.25 is 1/4.
That's the right answer, yeah.
And if this is just 1/4, then I just need, this is a 1. I need 4 here, so that has to be 3.
Yeah.
I didn't try to overthink it. I just used the obvious answer.
Yeah.
Got it?
Yeah.
All right.
We don't have to do 44.
What's that?
We don't have to do 44. I kind of just put 2 problems to like show you can see like the explanation part at the top.
Well, yeah, we can do 44.
Okay.
I'm not afraid of it. It just might be a little bit tricky if we're going to do separation of variables again. Let's find out how that's going to work. So we've got, I'm going to bring this over to this side and I'm going to divide by that, right? So we've got dy over root y equals 4 ln x over x dx.
So do you try to get all your x's by dx and all your dy's with y?
Correct. I'm trying to get the y's by themselves and the x's by themselves.
So you take an integral of both.
So, well, first of all, let's write what that equals, simplified a little bit. This is y to the negative 1/2 power dy, right?
Yes.
And this one is a little trickier. For the sake of simplicity, let's put the 1/4 in front of this. So it's divide by the 4. So it's because we already have enough to deal with over here.
Yeah. Sorry, how do you take an integral of the dy over root y? It like hurts my brain.
So I didn't take the integral, I rewrote it.
Okay.
What's the square root mean?
It means a 2 in the fraction, right?
It means a 1/2 power. But if it's on the bottom, I want to bring it to the top. I have to make it negative.
Okay. Yeah.
So for this one, we're going to have to do U-substitution, I believe.
Okay. So how do you use do sub, u sub in a
U equals
differential?
ln of x. What's the derivative of ln of x? Isn't it 1 over x?
Oh, yeah, that's what it is. Because ln equals 1 over u. So yeah,
That's why I'm using U sub, because I can see that that's going to work out nicely for me.
yeah.
So this equals U du, right?
Yeah. 1/4. And then do you just keep the 1/4? Yeah. So then you take an integral to cancel out the du on the other
Perfect.
side.
So this is just going to be U squared, 1/2 U squared plus C. And this is going to be 1/4
So it's gonna be
y
half,
to the negative or positive half
half. Yeah. So that means 2y.
times 2 over 1.
Yeah. Yeah. Wait. Yeah. Did you get the 2/1 from 2y from the reciprocal?
I'm dividing by this.
Yeah, exactly. Yeah, exactly. That's what I'm saying.
Yep.
Perfect.
So then that just equals 1/2 square root of y equals 1/2 u, which is ln of x squared plus c.
So we just
So
need to
it's
find a way to get what is it? Y by itself here,
yeah.
right?
Let's multiply everything by 2.
Yep. Which is just ln x squared plus c.
Yep. Now let's
And then you take the square root of.
No, now we're going
So
to square both sides.
oh yeah, you square both sides. So that's 4th. So that's ln x to the 4th plus c squared.
Nope.
It's just that.
I think we have to keep that c in there
Okay.
at that point.
So if y equals 1, wait a minute. Okay, wait. This is
So
pointing like
now I'm going to
this is
plug
pointing like
in
the ln e, which equals 1, correct?
1 equals ln of e squared plus c squared. And ln of, yeah, this just equals 1.
1. So wait, 0?
So c equals 0, I think. Yeah.
So then it's just y equals ln x to the 4th, right? Yeah.
Yep.
Perfect.
See, now you can say that because there's no other term.
I hate looking at a calculus problem, and I just hate seeing e's and ln's. Like I just hate them so much. Like
yeah. Okay, makes sense.
yes.
Was that answer right?
Yeah.
All right. I don't know slope fields, dude.
You don't.
I can kind of explain it to you, but I'm not really good at it.
Okay.
So what you're going to do is you're going to take the point 1, 1. The slope is equal to whatever x plus y is. So the slope at 1, 1 is 1 plus 1, which is 2, I believe. So if the slope is 2, it's going to be like over from here, it's going to be rise over run. It's going to be like that.
So you just fill it out like that, yeah.
So you draw the line like that.
So then the wider would be 3, and then 4, and then 5. Okay.
Right. So 3. So for this point right here, the point is 2, 1. The slope is 3, so it's going to be even steeper.
Yeah.
For this point right here, 0, 0, the slope is 0, which means it's a horizontal line.
Yeah, exactly.
For this point right here, the slope is 1, So it's going to be that nice standard over 1 up 1. For here, the slope is 2, so it's a little steeper. Do you get what I'm saying?
Yeah.
Does that look like what it looks like on your graph?
Oh, I don't think we have answers for these ones.
The
Because like,
slope of this is 1. The slope of this is 2. It's steeper. The slope of this is 3. It's even steeper. Get what I'm doing?
yeah, yeah, that's
This is
easy.
also 3 right here. It's steeper. This is 4. It's even steeper.
The
This
corner
is
would be the
even
highest.
steeper. Yeah, you get it. And then over here, it's going to be negative 0, -1. So the slope is -1. So it's going to be going down. 1, this point right here, the slope is 0 because it's over 1, down 1. Got it?
Yeah.
This is also 0, over 1, down 1. This is also 0 to the left. Do you see? Over 1, up 1.
Yeah.
Over 1, up 1.
Yeah.
So there's patterns that you kind of notice about this.
Do you use the negatives in those situations?
But those were, all of these ones were 0
Oh yeah, because yeah.
because the X and Y's cancel each other out.
Yeah. That makes sense.
Yeah. Okay. So, and then you can you fill out all of them like that. So this is negative and negative, right here. Sorry, this is -1 right here. So this is also like this. Got it. This one is -2, so it's steeper, but it's negative. Got it. This is also -2 right here. Steeper and negative. This is -3, so even steeper negative. This is -4, so even steeper negative. This is -6. I'm sorry, that was -5. I should have said this is -6, so it's the steepest negative. You get it?
Yeah.
So that's how you write slope fields. And it gives you a picture of what's happening. Remember, slope has to do with rate of change. And when you get used to using slope fields, a picture of a slope field gives you a visualization of kind of like a wave. It helps you understand where it's negative and where it's
Yeah.
right? It helps you understand what the function maybe would have looked like, because remember, it means it's increasing.
Yeah.
If it's a positive slope, it means it's a max or min point. So here's a max or min point. Here's a max or min point. I'm sorry. Yeah, here's a slope of 0. There's a max min point. It's going up. I believe that's how you do that, but you don't have the answer key for it.
No, I don't. That's like the only thing they don't have answers for. But that is right, I'm very sure. Because when we did it in class, we did something like that. It was similar. Should be fine.
I'm looking up slope field example.
Okay.
Pretty sure that's how that worked. This explanation did not help. How to draw a slope field. Yeah, there's some good. Hey, there's an example of this exact one.
So now we need to draw a line with a slope of 1. And then when x is 2, the slope is going to be 2.
Yeah, that's right.
So we
What I
see
did is
that
right.
is x plus c. We're going to follow the same process. And y is 0. When x is 1 unit higher than y, 1 minus 0 will be 1.
Yeah.
So we're going to have,
Yeah, we're doing it right, I believe. So for this number 48, again, just plug in, it's undefined wherever x is 0, it's undefined because you can't divide by 0. So you don't draw anything in for these ones.
Yeah.
And wherever y is 0, the slope is 0. So all of these are going to just be 0. You actually don't have to draw arrows on these, by the way. Got it? So those are all
Yeah.
0.
Yeah. Makes sense.
And then when wherever x is 1, so for all of these ones, it's just going to be the negative of what the y value was. So these are all going to be down, but increasing in slope, or a negative slope, I should say, right? So that's going to be down and -1, that's going to be -2, that's going to be -3. Got it? And these ones down here, like below it, are going to be the opposite. That's going to be +1, +2, +3. Got it?
Yeah.
And the same with down, let's see, where y is, so now, and for where x is -1, for all of these points, the negative cancels with that. So now these are just going to be here. And these ones are going to be reflected here, kind of. You know what I'm saying?
Yeah.
There's a +1, there's a +2, there's a +3, there's a -1, there's a -2, and there's a -3. A -2, I did a little too slow, a little too slanty. Okay, and then etc. You can keep going.
Yeah.
All right. All right, I think it's time to run.
Yeah. No, we're good. I'm gonna sign up for 2 more sessions so we can complete the jam board. Don't worry.
Sweet. And also check out those couple things that I weren't sure about. Maybe talk to your teacher, see if you can just get some extra help on those.
Yeah. I got you.
All right, bud.
Yes. Thank you so much.
No problem. I'll see you.
At least I don't have to take my test till next Monday and Tuesday, so I'll just
Yeah, that's awesome.